Hello everyone, welcome back to my channel. So today I'm going to make a video on how to write the notebook for the reaction synthesis, organic reaction synthesis, how to do the calculation. So to understand that part, you need to know some basic things. So let's take an example of a reaction and then let me do some calculations, and finally I'll show the overall picture of a reactions. So now let's take an example that we want to do a reaction like so let's take an example here. So we have benzene ring and alkylated fluorine. This is called alkylated fluorine. So 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6 6 carbons, like hexyl group, two hexyl group. Now this point and this point we can attach acyl group by reacting with benzoyl chloride by Friedel-Crafts acylation. So if we take an example like ClBr, then you will get product so in both side you will get that product Friedel-Crafts acylation. So now first of all find the limiting reagent, like which molecule we can use little excess that cannot be limiting reagent. So suppose here this molecule A and B and your product is C. So so in this reaction most of the time you need to know which molecule we can use little excess. The which one is little excess, that cannot be the limiting reagent. And here we can also use aluminum chloride for the Friedel-Crafts acylation, and solvent is carbon disulfide CS2. So any reagent, this aluminum chloride is a catalyst, so any reagent that acts as a catalyst or sodium hydroxide or acid or base, those cannot be the part of the limiting reagent. So you have to find out the limiting reagent in between A and B. So now since we want to attach B in both side of the A, so we need to add little bit more B here. But if we add more A here, then B will be less or shorter, so it will do one side attachment. So that's how you have to find out which one is the limiting reagent, like which one which one of the molecule, the concentration or amount, you will use fixed amount, not more than that. So among A and B you can use A should be fixed and B amount you can use little bit more. That's why A is the limiting reagent for this reaction. Okay, so based on that limiting reagent you can decide the calculation. So now let's do how you will write the calculation part. So here you can say starting material, then you can say equivalent, how much equivalent you will take, and formula weight or molecular weight, millimole, and gram or amount, not gram. Actually I can say let's write it the amount. So since we already know A is the limiting reagent, so for this reaction design you can decide like how much scale of this reaction you want to do. Suppose I want to do 5-gram scale of A. So in that case, I can write A or the name of the starting material, and it should be 1 equivalent because it is the limiting reagent. So limiting reagent always will be 1 equivalent. And formula weight of this molecule, so it is called, A is called 99 dihexyl fluorine molecule, and its molecular weight is let me find 334.54. So 334.54. And now if I want to do the 5-gram scale reaction, 5 gram, so you can think it's like 5,000 milligram. So to calculate the millimole, you need to convert this gram unit to milligram unit, and then divide that milligram with the formula weight, then you will get the millimole. So normally that 5 gram times 1000 divided by molecular weight 334.54. So here the millimole is 5.98 millimole. Okay, so remember always, like, the limiting reagent, find the limiting reagent, and whatever the amount you are taking, that amount times 1000. So maybe I can show you more clearly. So here take 1000, and divide the molecular mass, then you will get the millimole. So once you get the millimole, now you can decide the B, the starting material B. Now how much equivalent we are going to use? Normally it requires 2 equivalent to attach in both sides, but since it is not limiting reagent, we will use little bit excess. So we are taking here 2.8 equivalent. So 2.8 equivalent means, let me draw a little bit down, otherwise you will be confused with that number. So here we are taking B, and equivalent will be 2.8 equivalent, and its molecular mass is 219.46. that B, actually I'm talking about this B, like 2-bromobenzoyl chloride. So molecular mass is 219.46. Now the limiting reagent millimole is 5.98, but the B will be that 2.8 equivalent of that millimole. So I want to say like 5.98 times 2.8. So it will be 16.74 millimole. Now to get the amount, you can multiply this millimole with this formula weight or molecular weight to get the amount. That will be like 3.678 something or something. So you will get whatever you will get this amount. So let me do more clearly. So 16.74 times 219.46 divided by 1000. So that will be in a gram, because if you multiply millimole into molecular weight, you will get as a milligram, but if you divide with the 1000, then you will get it as a gram. So you will need 3.67 gram. So by this way you can get the amount. Now we are using aluminum chloride also. So aluminum chloride, we will be using 4 equivalent for this reaction. 4 equivalent means again the 4 equivalent of the millimole of the limiting reagent. So aluminum chloride molecular mass is 133.3. So 133.3, and 4 equivalent of like millimole will be 5.98 times 4. So it will be like 24. not 24 actually, little bit more. So let's calculate it how much it is. So for equivalent, where is the calculator? So let's calculate 5.98 times 4. It will be 23.992, like almost 24. So 23.92. Now you can get the amount. So now multiply this 23.92 times 133, these two, then divide by 1000. So you will get what is the amount? 3.19, around 3.19 gram in gram unit. And now write the solvent. You are using carbon disulfide, and you don't need to write the equivalent or molecular weight or anything. Just write how much solvent you are using, like 40 milliliter. So this will be a reaction scheme. So you need to write the reaction first, find out the limiting reagent, and then list the starting material, and then write down the limiting reagent and as a one equivalent and its formula weight or molecular weight, and then millimole and the amount. So how much amount you want to use as a limiting reagent. So based on that amount, you can calculate others like B and other reagent, whatever the reagent you will need. Just you need to know how much equivalent you are going to use. So here B is getting used 2.8 equivalent, and aluminum chloride is going to we are going to use 4 equivalent. So we can calculate in that way. So by this way you can just mix all those things depending on the procedure. So next step should be like procedure. You can write procedure literally. So procedure, then you can say 5 gram, how much millimole? 5.98 millimole of A was mixed with 3.67 gram, that would be 16.74 millimole of B, and then 3.19 gram or 23.92 millimole of aluminum chloride was mixed. Finally, 40 ml of carbon disulfide was added in the reaction mixture, and the reaction was stirred. Now you need to say whether this reaction will be stirred at room temperature or like certain degree of temperature, whatever, or ice. So stirred at, suppose we are doing room temperature RT for how long? Like maybe 12 hours. So we can say 12 hours. So this is the procedure you're writing. Then once you get the reaction, then workup. So you need to also record the workup, how you are going to work up. Some people do workup with, if it is acid base reaction or something, or like byproduct is acidic, or like since aluminum chloride is kind of acidic, like so you have to add a little bit like water to quench the reaction, or like you can add a little bit sodium bicarbonate to quench the reaction. So you have to record that, like whatever the procedure you use to quench the reaction. Then write the mass of the crude amount, mass of the crude, how much, suppose x gram. Okay, and after that, after purification, suppose you get mass of the pure product, mass of the pure product, pure compound or product, suppose it is y gram. So product means this product. Okay, so here this product. So you need to know the molecular mass of this product. That is because to calculate the yield, you need to know the molecular weight of this product. So it is like 705.54. So now from this, if you know the, like you get the pure product y gram, so in that case you need to, you can calculate the um, yield, percent yield, so 8 gram. So now you have to calculate mass as expected, mass expected. That would be how much you want, like expect. That would be molecular mass of the product molecular weight or mass of the product times amount of limiting reagent you used. Divided by molecular weight of limiting reagent. So here molecular weight of the product is 700.54 times limiting reagent was used as a 5 gram. So if you see in the here, so this molecular weight is 700.54 and the limiting reagent was used 5 gram, like A. Okay, so here you can put those information, and the molecular weight of the limiting reagent means A was the limiting reagent. So here molecular weight of the limiting reagent is 334.54. so you can find out 334.54. so find the amount. So that will be your expected mass expected. So 700.54 times 5 divided by 334.54. So your expected mass is 10.47 gram. Okay, now you got, originally remember you got 8 gram as a pure after purification. Suppose you get the mass as a crude like something gram, and after purification you get mass as a 8 gram as a pure. So now you can calculate the percent yield. So percent yield will be the pure mass you get over the mass you are expecting gram time 100%. So your percent yield will be 8 over 10.47 times 100, that will be like 76.4. So 76.4%. So remember, let's do more fresh way how you like. So I hope you understand the part, like the calculation here. um, So when you have the two molecule to give the product and find out the limiting reagent and then calculate the millimole equivalent in terms of equivalent and then find out the amount and then procedure, then find out the mass and then find out the pure product and now mass expected. So molecular weight of the product times amount of limiting reagent you used. Limiting reagent originally used in the beginning of the reaction and divided by molecular weight of limiting reagent. So product mass is 754 by molecular limiting reagent you use 5 gram and molecular mass of the limiting reagent is this and then you will get the mass expected. So now calculate the percent of yield, that will be your pure amount you find divided by you expecting time 100, so you will get the percent of yield. Okay, so what we have learned, so suppose A and B is reacting to give C, okay, and A is the limiting reagent, like which is you need to use fixed amount, and B is like arbitrary, like little bit more, it's fine. So in that case, know the molecular weight of A, suppose equal to X, molecular weight of B is Y, and molecular weight of C is suppose P. Okay, now so suppose we are using starting material equivalent formula weight or molecular weight. Let's do like as a molecular weight, millimole and amount. So starting material A, if we want to take 10 gram, so like 10,000 milligram, and suppose formula weight is 200, and we are going to use one equivalent. So millimole will be 10 gram, means 10,000 gram by 2, like molecular weight. So 10,000 divided by molecular weight 200. So whatever the amount you are getting, suppose it is m millimole, not m, let's, since the millimole is same, so suppose P is suppose okay, let's find out 0,000, so 200, so 50, it will be 50 millimole. So once you know the millimole of the limiting reagent, then you can easily find out B. So you have to decide how much B you are going to use. Is it like 1.5 equivalent or 2 equivalent or 3 equivalent, whatever equivalent you can find out from the procedure. So suppose we are going to use 2.5 equivalent. So and B molecular weight is suppose 100. So 50 millimole. So B will be 50 times 2.5, because that equivalent will be multiplied with the millimole, never ever with the molecular weight or never ever with the amount. So you will get 50 times 2.5. So 50 times 2.5 will be how much? 50 times 2.5 will be 125 millimole. Now once you get the millimole, so that millimole and the molecular weight, multiply these two to get the amount as a milligram. So you will get as a milligram. So 12500 milligram, and you can get 125 gram. So if you divide by 100, sorry, 1000, so what, sorry, not 125, it will be 12.5 gram, because you need to divide by 1000, so it will be 12.5 gram. Yes, so it will be 12.5 gram. Now if sometimes suppose originally your B is say sell as a like 70%. Sometimes it says like many reagent is like commercially available like certain percent, even it is solid. So in that case, first calculate that B as like normal way, like taking as 100%. So you need 12.5 gram as 100% if B was in 100%. But since B is like 70% present, so in that case you have to find out the real amount you need. In that case you have to multiply by 100 over the percent. So 70% means like just divide that amount and times 100. So you will need a little bit more. It is basic, right? So if your B is 100%, so you would need 12.5 gram. But since 70%, that means B as active 70%, like less than 100%. So in that case you need little bit more. So that's how you just multiply 100 and over 70, so you will get little bit more amount, like you will require more amount. So by doing calculation we are getting 17.85 gram. So this is another things to know. In some cases, suppose see another product, sorry, see another reagent you need, like, or reactant, like suppose n-butyl lithium or like any other hydrogen peroxide or like tbaf, etc. And it is in a solution, like it says 1 molar solution in THF. Okay, so in that case how you are going to calculate how much you need, and you know that like you need suppose you need one equivalent, C is one equivalent. So original limiting reagent, how much for the limiting reagent? Millimole 50. So C need one equivalent, so C also need 50 millimole. So 50 millimole. So if it is like 1 molar, so in that case how much you need, since it is a liquid? So amount you need, remember that if it is 1 molar, so amount will be like that 50 millimole by that 1 molar, millimole. So you will need 50 milliliter of it. Remember that if C is 2 molar, then you have to divide by 2, then like you could say 50 by 2, that means you need 25 milliliter of that liquid reagent. So whatever the molar, if it is say if C is like 0.5 molar, then it could be like divide 50 divided by 0.5, so it would require 100 milliliter. Like if you take 50 by 0.5, so by this way you can calculate how much liquid reagent you need. Okay, another thing is in some cases direct liquid reagent, not molar or something, suppose cyclohexanone, okay, you need it. So in that case, suppose you take 1.5 equivalent, so that will be 50 times 1.5. How much it would be? So 50 times 1.5 equivalent, so it will be 75 millimolar. And suppose cyclohexane molecular weight is x gram, so now you need 75 millimolar times x divided by 1000, it will be like suppose y gram. But since it is a liquid, sometimes it is tough to measure the liquid as a gram. So in that case, you can convert that required gram in a volume. How? Because we know density equal to m over v. So in that case, v, volume, equal to m over d. So m is that required amount, y gram, over the density. So density, like density of the cyclohexanone. So whatever the density of cyclohexanone, so you can use the density, and then you can get whatever the, remember that amount should be in gram. okay, gram y gram over density. So whatever amount you will get, that will amount you will need as a milliliter. So liquid reagent, direct reagent can be calculated. First calculate how much gram you require, then convert is as a volume. Or if the liquid reagent is in like certain concentration solution, then you can calculate how much amount you need. So if you have any more question, just you can ask me. I i I will try to answer.